we got an integration of a rational function, and the bottom looks like we can factor the bottom in this way, x plus 2 over, the goal here is to write this fraction as a sum of simpler fractions, and the bottom we can factor x cube x square out, and remains x minus 2. Okay, so we want to write now, if possible, x plus 2 over x square x minus 2 as a sum of simpler fractions. Okay, so we have x square, repeated root here. For the repeated root case, it works in this way, x plus x square, we need to write both, and just constant on the top, and third just a linear factor x minus 2 and another constant on the top. Okay, so this is the way we want to write this fraction. So a over x dx, and second fraction will be b over x square, plus the third will be c over x minus 2. Okay, so we can write this fraction as a sum of partial fractions. Now let's integrate, and we'll go back and find the values of a, b, and c. We can pull a outside, constant, 1 over x, integration of 1 over x is just natural log of x, plus pull b over 1 over x square. This is not natural log of x square. 1 over x square, let me show you over here. 1 over x square is same as x to the negative 2. Now xn, we can use power rule in this case, x n plus 1 over n plus 1, which is x to the negative 1 over negative 1. Negative in the front, x to the negative 1 is 1 over x. Okay, so the antiderivative of 1 over x square is negative 1 over x. So b times negative 1 over x, plus the derivative of bottom, we can pull c outside, derivative of bottom is 1. Okay, and integration of 1 over x minus 2 is just natural log of x minus 2 plus c. As soon as we find the values of a, b, and c, now we have to use different constant because c is there. Let me write c1, where c1 is an arbitrary constant. We'll find a, b, and c from this relation, from this equation, then we are done. Okay, for that let me erase this part. To find the values of a, b, and c, we want to multiply both sides by the common denominator, which is x square x minus 2. Okay, so we multiply left side by the common denominator x square x minus 2. Same thing, multiply each fraction by x square times x minus 2. On the left, everything cancels, just the top survives, x plus 2. So let me write over here on x plus 2 equals, when we multiply first fraction by x square x minus 2, 1x cancel, so a 1x times quantity x minus 2, so a x x minus 2 plus x square cancel, so b x minus 2, b x minus 2 plus x minus 2 cancels, c x square. Now this, since this equation is true for all real values of x, we will choose x cleverly so that we can find the values of a, b, and c. If we take, let's see, x equals 0, then a times 0, this term is gone, and c times 0 square, this term is also gone. Okay, in this way we can find the value of b. Okay, x equals 0, taking x equals 0 implies 0 plus 2, 2 in the left side, a times 0, just 0, b times 0 minus 2 minus 2 minus 2b plus c times 0 just 0. This gives b equals 2 divided by negative 2, so negative 1. Okay, out of 3 constants we now know b. Let's take x equals x minus 2. Let's take x equals 2. Then 2 minus 2, this will be gone, so 2 plus 2, 4 in the left side, this is 0, 2 minus 2 0, c times 2 square 4, so 4c, or divide by 4, c equals 1. Okay, now we need to find the value of a. 0 is used, 2 is also used, and we need to find only 1, so we can take any value. Let's take x equals 1. That gives 1 plus 2 3, 1 minus 2, this is negative 1 times 1, this is negative 1b, so negative a, we are taking 1, right? So 1 times negative 2, negative 1 times b is already found negative 1, so negative 1 times negative 1, positive 1, c equals 1, 1 is square, oh we are taking x equals 1, 1 is square, 1 times c is also 1, so 1 plus 1, so 1 plus 1 2, move that 2 over, so 3 minus 2, 1 equals negative a, or a equals negative 1. Now we go back and plug in those values, done. A is negative 1, minus plus minus, this will be negative, but b is negative 1, so negative 1 times negative, so positive 1 over x, plus c is 1, so 1 times natural x minus 2, plus c1, where c1 is an arbitrary constant. If you like, you can combine these two terms, but this could be a good answer. This is already a good answer. Let me combine the 1 over x, so I want to combine these two. Okay, natural log of x minus 2 minus natural log of x. You can take this to the top, but this is basically natural log of difference. When we know natural log of a minus natural log of b, that's natural log of quotient. Okay, so natural log of a minus natural log of b is natural log of x minus 2 divided by natural log of x plus 1 over x plus c1. Okay, this is the final answer, where c1 is an arbitrary constant.